You know how DevOps transformed the way we build and ship products? Well, that was until machine learning came around and threw a giant wrench into it. That's when the terminology MLOps was born. This fancy buzzword everybody's using around, but very few can actually clearly explain it. Well, you are in luck because today in this video, I'm going to break it down for you and explain to you the difference between DevOps and MLOps. So stick around. Hi, I'm Edna. Welcome to my channel. I help software professionals grow their skills, but also become more productive by using AI powered tools and workflows. I've been in tech for over a decade now, and I've been through it all: the promotions, the layoff, burnout, all of it, which made me rethink everything. I never forget that morning when I realized that I had lost access to my work account. First, I thought, oh man, I must have finally broken VPN with having too many tabs open in my Chrome browser. But then the Slack messages started coming in, and I realized that I was laid off. That moment inspired me to view my career from a different lens and create the space for real talk and real growth. I publish videos every week, so make sure to hit that subscribe button so you won't miss out. Software teams nail DevOps: continuous integration, continuous deployment, monitoring. They did it really well because in most software applications, code is king. But for ML applications, the code isn't enough. There's data to think about, there's the models, and the fact that things change very frequently. One day your model might work great, and the next day the data distribution changes, and then there you go, your model is trash, the predictions of it. So that's where ML Ops was born to bridge that gap. DevOps is like running a restaurant with a fixed menu. You know the recipes, you know the ingredients for them, and therefore your kitchen runs very smoothly day to day. But ML Ops is like running the same restaurant, but where the ingredients for those recipes change every day. And therefore, your customer's taste changes every day. So you need extra systems to test, adapt, and stay consistent on how your dishes taste. If you've enjoyed this video so far, I would really appreciate it if you hit that like button, comment, and also share it. And if you haven't subscribed already to my channel, hit that subscribe button. I would really appreciate it because it's going to help the channel grow, but also show this content to others who might find it useful. And in return, I promise I will answer all of your comments, so make sure to add some comments. But also, here's a cute picture of my dog, Kaden. All right, let's continue, shall we? Oh, and make sure you stay till the end because I have a nerdy dad joke for you. Here's a strategy. ML Ops extends DevOps in four key areas. First, it doesn't just version the code, it does version the data, but also the models. Two, automated training pipelines. So every time it detects that there's new data, it retrains the model. Three, the deployment of the models into the real world, into production. And fourth, the continuous monitoring because it needs to check, right? Things change very often, so it needs to monitor those drifts and performance degrades. So instead of just saying CI CD, the new acronym is CI CD CTCM. Say that fast. CI/CD CTCM stands for continuous integration, continuous deployment, continuous training, and continuous monitoring. All right, let's go over a demo in Hugging Face to see visually how all of this works. Step one, we're going to track experiments on WNB dashboard. Every training run is automatically logged here: parameters, metrics, and artifacts. I can instantly compare different models, just like, browsing Netflix, but for my experiments. Quick metrics tour. Three numbers tell our model's story. Test accuracy is the percentage of the correct predictions on data the model never saw. It's computed as correct predictions divided by total test samples, and it's the best quick check of how well the model generalizes. Well, unlike training accuracy, which can overfit. N underscore rows is the size of the full data set before the train or test split. In this iris demo, that's 150 rows, about 112 for training and 38 for testing with a 25% split. N features is how many inputs the model uses. Here we have four: sepal length, sepal width, petal length, and petal width. The iris dataset itself is a classic: 150 flower samples across three species: Setosa, versicolor, and virginica. 50 of each. The task is to predict the species from those four measurements. And y'all, you know how much I love flowers, so no surprise, I chose this. So remember, how well does it perform? Test accuracy. How much data did we use and rows? And what does the model see as input? It's N underscore features. All right, let's continue. Step 2, register the best model. W and B registry. Once I pick the winner, I don't leave it buried in my laptop, right? I register it here, version it, and promote it from staging to production. One click, and everyone knows which model is live. Step number 3 would be to serve with a Gradio app on Hugging Face Spaces, actually. This is my deployed model, running inside a simple Gradio app on Hugging Face Spaces. By the way, I hope I pronounced that correctly. Anyone on the team can try it out. No environment setup is needed. It's like giving your model its own little web kiosk. Step number 4 is to monitor drift with evidence. But models age. Here's an evidently drift report comparing last week's data with this week's. See how the distribution shifts? If drift crosses a threshold, we trigger retraining. This way, the system adapts as the real world changes. Isn't that awesome? If you like this video, I would really appreciate it if you hit that like button, comment on it, and also share it. And if you haven't subscribed already, please go ahead and hit that subscribe button. It really helps the channel grow, but also to help show this content to others who might find it helpful. And I will be forever grateful to you. And now I leave you, like I always do, with a joke, because life is too short not to laugh. Why was the ML model stressed? Because it had too many parameters to manage. Ah,